Shipping MCP servers into production is more than an engineering milestone. It is a governance challenge. In this lesson, we'll look at how approvals, policy controls, monitoring, and compliance turn powerful tools into a safe, accountable production capability. So far, we've built from the MCP mental model into secure access, reliable tool behavior, and production operations. Now those pieces need coordination. Governance turns good engineering practices into an organizational system, with clear ownership, approvals, policy enforcement, and evidence for compliance. That foundation leads directly into the next topic: incident response and production readiness. An MCP tool is not just an API wrapper. It may allow an AI to read sensitive data, launch workflows, or change business records. Governance answers the critical question: who approved this access, under what rules, and how can we prove it was used safely? A governance model turns MCP servers from one-off integrations into managed enterprise assets. Each server needs clear ownership: who is accountable for business value, who owns the technical design, and who operates it day to day. Reviews should scale with risk. A read-only, low-sensitivity tool may need lightweight approval, while a tool that changes systems or accesses regulated data needs deeper security and compliance review. Documentation is part of that governance: purpose, schemas, permissions, data handling, and runbooks. The lifecycle matters too, from proposal and build through production monitoring to safe deprecation. Risk classification helps you avoid treating every MCP tool the same. Start with the data. Public information needs different controls than regulated or highly restricted records. Then look at the action. A read-only lookup is very different from changing accounts, moving money, or deleting production resources. Also consider how the tool runs. Delegated user access, service credentials, tenant boundaries, and external integrations all affect risk. The tier you assign should drive approvals, logging, test depth, and release controls. The goal is proportional effort, not blanket friction. Policy should be enforced by the MCP runtime, not left as a document people are expected to remember. Before a tool runs, the request should be checked for identity, tenant, scope, consent, and the specific action being requested. Inputs should then be validated against schema and minimized, so the tool receives only what it needs. After execution, responses should be filtered to avoid leaking excess data. Each step should produce audit evidence: who invoked what, under which authorization context, when, and with what outcome. These controls can be enforced through policy engines, gateways, middleware, or service code. Think of the MCP registry as the control plane for governance. Every server should have a clear purpose, accountable owner, runtime environment, deployment topology, and supported clients. Every tool needs a catalog entry explaining what it does, what schemas it accepts and returns, what permissions it requires, and what side effects or risks it carries. Then add operational proof: SLOs, runbooks, escalation contacts, versions, and deprecation timelines. Finally, connect the evidence, including approvals, security reviews, compliance mappings, and audit log locations, so teams can trust what is running. Approval should begin before a tool reaches production. The intake proposal needs to explain what the MCP tool does, who will use it, what data it touches, what actions it can take, and why the business needs it. From there, risk triage determines the review path. Low-risk tools can move quickly. Higher-risk tools bring in engineering, security, privacy, compliance, and business owners. Before approval, require proof that tests pass, permissions are correct, telemetry exists, rollback is ready, and ownership is clear. Deployment then becomes a controlled release, not a leap of faith. Before approving an MCP tool, evaluate three things together: what it can see, what it can do, and what happens when it runs. Data sensitivity tells you whether the tool touches PII, secrets, financial records, health data, tenant data, or regulated information. Permissions should be no broader than the task requires, and they should match either the user's delegation or the service identity. Then examine side effects. Reading is different from creating, deleting, purchasing, approving, or notifying. High-risk actions need compensating controls, such as confirmation steps, approvals, dry runs, audit logs, or human review, especially when failure could harm systems or customers. A tool is not approval ready just because its core action works. It must also be understandable, observable, testable, and reversible. Clear names reduce mistaken use by both AI clients and human reviewers. Testing should go beyond happy paths, covering schemas, authorization, edge cases, retries, failures, and adversarial prompts. Logging should preserve the events needed to reconstruct decisions without turning sensitive data into a new risk. Rollback must be practical, not theoretical. Use feature flags, version pinning, tool-level disablement, and back-end reversions, so a bad release can be contained quickly. Compliance starts by tracing the full data path. A user request may pass through the MCP server, trigger tools, reach back-end systems, create logs and traces, and return a response. Each step needs an explicit control. Validate inputs, authorize access, minimize data, encrypt sensitive fields, mask or redact PII, and filter outputs before anything reaches the user. The key question is this data necessary for the approved tasks? Those decisions should then align with your policies and obligations, such as SOC2, ISO 27001, GDPR, HIPAA, or sector-specific rules. Governance only works if you can prove it later. For MCP systems, that means capturing audit events across the full lifecycle: registration, approvals, permission changes, invocations, failures, overrides, and deprecation. Not every signal serves the same purpose. Operational telemetry helps teams run the system day to day, while formal audit records need stronger integrity, longer retention, and controlled access. Define retention by artifact, including approval records, security reviews, incident reports, version changes, and invocation logs. The goal is simple. When auditors, customers, regulators, or investigators ask, the evidence is complete and retrievable. MCP governance also has to answer two boundary questions. Where is this data allowed to go, and whose data is it? Regional controls enforce residency rules for storage, processing, logging, and telemetry. Tenant isolation ensures one customer's context never appears in another customer's authorization decision, cache entry, database query, vector search, or tool response. The risky leaks are often indirect through error messages, shared prompts, search results, or diagnostic logs. Approval should therefore document the regional model, any permitted cross-region flows, and the assumptions that keep tenant boundaries intact. Governance should move at the same speed as development. Start by putting policy checks into pull requests and code review. Then enforce them again in CI/CD, testing, release approval, and change management. Any meaningful tool change should trigger reassessment. New schemas, broader permissions, new integrations, sensitive data types, or new side effects. After deployment, monitoring becomes another control point, watching for violations, unusual invocation patterns, error spikes, and unexpected behavior. Exceptions can exist, but they need an owner, an expiration date, documented risk acceptance, and a remediation plan. To scale MCP safely, governance must be operational, not theoretical. Define owners, classify risk, document decisions, and manage tools through their lifecycle. Approve tools only after checking data sensitivity, permissions, side effects, logs, tests, and rollback paths. Compliance then rests on evidence, isolation, auditability, and regional controls. Next, we'll apply this foundation to incident response and production readiness.